Bismillahirrahmanirrahim. Dalton's law. This is the last law that we'll discuss. Okay, so this Dalton's law is about the partial pressure of the gas. Okay, and it states that if we have a mixture of unreacting gases, okay, we have several gases that are mixed, okay, and they are not reacted in the same container, the total pressure, okay, in the container is the sum of the partial pressure of the individual gases. Okay, this is the Dalton's law statement. So if let's say we have two gases here in this container, we have A gas and B gas, okay, so that the total pressure in this container is actually the sum of the partial pressure of the first gas or gas A and the partial pressure of gas B. So due to that, P total will be equal to PA plus PB. P total is the pressure total, PA is the partial pressure of gas A, PB is the partial pressure of gas B. So what is the partial pressure? It is actually the pressure that the gas would exert if it were present alone in the container. Okay, it means that if let's say in this container, okay, we have only A, gas A in this, okay, if let's say A exert 2 atm, okay, and then when A is mixed with B, then the partial pressure of A still 2 atm. That is the partial pressure. It is the pressure exerted by that specific gas, okay. It's either it's present alone, it is the only gas in the container, or it is in a mixture. So example is given here. If you have a mixture of the nitrogen and hydrogen gas in the container, so the total pressure in this container will be equal to the partial pressure of the nitrogen gas plus with the partial pressure of the hydrogen gas. According to the ideal gas equation that we have learned before, the pressure is equal to nRT over V. Okay, so that if we said that the P total is equal to the partial pressure of A plus the partial pressure of B, it means that the number of mole PA is actually nRT over V. The number of mole of gas A multiply with the gas constant with the temperature over with the volume of the container, okay, and then it is plus B plus PB, so that it is means that plus number of mole of B multiply with the gas constant temperature over volume of the container. Okay, and since that these two gases A and B are in the same container, it means that A and B will have the same R, of course, because it is the gas constant, will have the same temperature because it is in the same container, and also the same volume because they occupy the same volume of container. Okay, what's different between these two is actually the number of mole of the first gas and the number of mole of the second gas. So that mole of gas A plus mole of gas B is equal to the total mole. So if we want to calculate P total, okay, it's either we calculate it one by one, okay, nART over V plus nBRT over V, or okay, if let's say we have the sum of the number of mole of the gases, so we can strictly use P total equal to N total RT over V. Okay, this is if we want to calculate the total pressure in the container. Okay, besides using PV equal to nRT, if let's say we have no information about V, and also we have no information about the temperature, okay, but the only information that we have in the question is the total pressure and also the amount. It's either in mass or mole. Okay, then we can use the second equation to determine the partial pressure of any gas, okay, which is the equation of partial pressure of A or PA is equal to XA multiplied with the total pressure, okay, in which XA is the mole fraction of the gas A in the mixture. So we have learned mole fraction in chapter 2. Okay, mole fraction of A, if let's say we have a mixture of A and also B in the container, so we will have the number of mole of gas A and also the number of mole of gas B. The mole fraction of gas A will be the number of mole of gas A over the total mole. Okay, mole A plus mole B. Then we will get the mole fraction. So if we want to calculate the pressure or the partial pressure of A only, so mole fraction of A multiply with the total pressure. So that if let's say we want to calculate the partial pressure of gas B, it is equal to the mole fraction of gas B multiply with the P total, in which XB is equal to NB over N total multiply with the P total.